Now the stroke you have enchanted. Ganaka Guna Nirupanam. Laghukarana, that means eight qualities should be there for a Ganaka. That is, for a mathematician, or for in general for any scholar. In general, for any scholar, 8 qualities should be there. What are they? Laghukarana, that should be brief, short, or precise. Whatever we say, it should be brief. It should be precise also. Laghukarana, uha. That means uha, desirable result. Uha. Apoha, that is undesirable result. Analasya, that is activeness. Grahana, grasping. Dharana, memory. Upaya, device. Vyaktikarana, make the unknown known. Laghukarana, once again, Laghukarana is brief or precise. Next, Uha. ऊहा करना, क्या होगा ये ऊहा करना है ना, ऊहा. ये नहीं होगा ये अपोहा. Once when I was giving lecture in a Gurukula, Maitri Gurukula near Bangalore, there is a residential school for girls. I said, suppose a couple after marriage about 5 years, 10 childs cannot be there. In 5 years, she cannot deliver 10 childs. Then suddenly a girl stood up. It is possible, sir. If this, then I have to change my statement and be precise. If we suppose that at each delivery only 1 child is delivered, then in 5 years 10 childs cannot be delivered by a woman. Then she accepted. So, I violated the first condition, precise. I was not precise. So, uha, apoha. There can be 5 childs. 1 child per year, so 5 childs, it is uha. There cannot be 10, that is apoha. Uha, apoha. Grahana, grasping the thing is grahana. Which we grasp, keeping in memory is dharana. Upaya, devices to know the unknown. Analysis, we should be, whenever we analyze, though we cannot make progress, that's why we should be active always. And which we think we should be able to communicate to the others, that is vedicmaths. These are the 8 qualities necessary for a mathematician, not only for a mathematician, for any scholar. Now, coming to our subject proper. Yesterday, we were studying about triangles. Now, triangle may be considered as a closed figure formed by 3 lines, or it can also be considered as the figure formed by 3 chords of a circle. 3 chords of a circle. If we define 3 sides of a triangle, then its shape will be unique. If we define 3 sides of a triangle, then its shape is unique. There may be only rotations. There cannot form different figure. It is the same figure with some change in the angle. It is not so with the case of quadrilateral. Now, we have considered only 6 parameters in a triangle, 3 sides and 3 angles. To construct a unit triangle, minimum 3 independent parameters. In case of a quadrilateral, 5 independent parameters. If we extend this principle to pentagon, hexagon, septagon, octagon, anagon, then what is the number of independent variables? The number of independent variables is equal to, I have compared with the trusses. Trusses in this engineering structural design. Write down the formula n is equal to n is equal to 2j minus 3. N is equal to 2j minus 3. N is equal to 2j minus 3. Where n is the number of members. Now you are seeing 4 members. One upper member, one lower member, 2 side members. This is not a perfect truss. You are seeing the truss, but it is not a perfect truss. It may be deformed. So, where n is the number of members and j is the number of joints. J is the number of joints. A truss to be perfect, it should conform to this equation. Now, coming to geometry, n is the number of sides, j is the number of vertices. N is the number of sides and j is the number of vertices. So, take any polygon. If it conforms to this, then the number of independent variables, it gives the number of independent. Take for example pentagon. Pentagon means 5 vertices. So, the number of vertices is 5. So, 2j is equal to 10. 10 minus 3 is equal to 7. There should be 7 independent parameters for the construction of a pentagon. It goes on that way. So, this is the general formula. How to think is like this, general way. In this general way, we are thinking. Next, coming to again 2-dimensional figure, 3-dimensional figure. Now, if we take a tetragon, draw an equilateral triangle. Join the midpoints. Again, one triangle. Now, it is an equilateral triangle. Midpoints are joined. So, there are 4 triangles. Now, take a paper, fold on these lines and take it above. It forms a tetrahedron. This thing in engineering terms is called generation of a tetrahedron. A tetrahedron can be generated by a triangle making 3 folds. When 3 folds are, now these are the sides of a triangle. When the sides of a triangle coincide, edges will fall. I think you are following.
Yes.
This is a triangle. I want to fold this triangle like this, and this triangle like this, and this triangle like this. So, then this will be the base. These 3 vertices make the upper vertex of the tetrahedron. So, these 3 will be the base edges, and 2 sides make 1 edge. So, now if we generate the cube, 6 squares. If we generate a cube, then we will have 6 faces, that is 6 squares. Now, first of all, we have seen about the tetrahedron, next a cube, then a pentagon in the middle, and 5 pentagons. Done patient that was 5 pentagons. Now, to make edges, 2 sides should coincide. Now here, what is the angle between these 2 sides? It is 180 degree. Here it is also 180 degree. Here also it is 180 degree. Now, when we fold on this line, so which are the 2 edges? Which are the 2 sides which make edges? This side and this side will coincide. What is the angle? 90 degree. In this case, it was 180 degree. So, in case of pentagon, now what is this internal angle? It is
180.
So these are 90. So 3 squares will join at a vertex. 3 squares will join at a vertex. एक जगह खाली है. जगह कितना खाली है? 90 डिग्री खाली है. यहाँ पर कितना जगह खाली है? 180 डिग्री खाली है. Extend. I will. This is a pentagon. Now, in a pentagon, कितना जगह खाली रहेगा? बीच में यहाँ पर एक स्क्वायर है, चारों तरफ स्क्वायर्स है, बीच में एंगल कितना है? 90 डिग्री. यहाँ पर बीच में एक ट्रायंगल है और ट्रायंगल्स और जो है 180 डिग्री. यहाँ पर बीच में एक पेंटागन रहेगा, 5 पेंटागन उसके अराउंड दैट लेवल में. सो एक पेंटागन दूसरा पेंटागन को नहीं लगेगा, बीच में जगह होगा, उस वास्ते उसको उठा सकते हैं. आई थिंक take a paper, draw a pentagon, and around it on each side a pentagon. So there will be 6 pentagons, and cut the space in between. So you can lift and make an edge. So by where 2 sides of a pentagon will join, there will be an edge.
They laying tiles in pentagon shapes. How many pavements and how they are laying tiles? No?
Yeah, I will come to that. So, what is the internal angle of a pentagon, regular pentagon?
70.
What is the internal angle of a pentagon? Padmanabh.
70.
72. More than 9. 110.
108.
How to calculate it?
108.
How?
540 is the sum of all the angles divided by the number of sides.
Another easy way. (360 by 5). How much it is?
72.
180 minus 72. 108. So there are, when we join 3 pentagons, what is the total angle? 108 into 3. It is 324 degree. खाली जगह कितना बचा? एक खाली जगह जो है ना 36 डिग्री बचा। हाँ, यहाँ पर 180 डिग्री था, यहाँ पर 90 डिग्री हुआ, यहाँ पर जो है ना 36 डिग्री। So when we teach Platonic solids, तो नाम जो है ना it is misnomer. However, we are teaching that for our convenience take the name itself. How many Platonic solids are there? ये जो है ना हाई स्कूल का सिलेबस का है। Platonic solids में what is the definition of a Platonic solid? Each phase should be similar. Tetrahedron is a Platonic solid because all the 4 faces are similar and they are equilateral triangles. And the cube is a Platonic solid because each face is a square. और एक बात क्या है? At the vertex, the number of planes joining should be equal. I think you have understood. एक वर्टेक्स जब फॉर्म होता है, ये वर्टेक्स में जितना प्लेन्स ज्वाइन होता है, वो ज्वाइन होने नंबर ऑफ प्लेन्स ज्वाइनिंग एट अ वर्टेक्स शुड बी इक्वल। वैसा सॉलिड्स को जो है ना हम प्लूटोनिक सॉलिड्स कहते हैं। आई थिंक यू हैव फॉलोड। Now here in case of a tetrahedron, मॉडल्स था टेट्राहेड्रन में each face में जो है ना 3 ट्रायंगल ज्वाइन होता है। वैसा ही इन सॉलिड्स इन क्यूब आल्सो 3 साइड्स ज्वाइन होता है। वैसा ही इसमें जो है ना 3 ज्वाइन होता है। एक वर्टेक्स पर एक वर्टेक्स। वैसा then we will calculate the number of vertices, number of edges, number of faces, etc. Now my question is, जैसा हर फेस ट्रायंगल वैसे उसको टेट्राहेड्रन बोल दे, इधर हर फेस स्क्वायर रहता है उसको क्यूब बोल दे, इधर हर फेस जो है पेंटागन रहता है उसको डिओडेकाहेड्रन बोल दे। Is there any other solids having each face as a hexagon, each face as a septagon, each face as a octagon? Is it possible? If possible, how many? If not possible, why not possible? I think you have understood the question. एक प्लूटोनिक सॉलिड में हम 3 सॉलिड का ले लिए। पहले जो है ना टेट्राहेड्रन है, सेकंड जो है ना क्यूब है, थर्ड जो है ना डिओडेकाहेड्रन है। ऐसा ही आगे सॉलिड बनेगा क्या? अगर बनेगा तो कौन सा उसका नाम क्या होगा, उसमें कितना फेसेस होगा, कितना एजेस होगा? अगर नहीं बनता है तो क्यों नहीं बनता?
Because the angle keeps reducing, it may not be.
So, if each face is a hexagon, then how many faces will be for the 3-dimensional hexagonal figure?
7 pages, right?
No. So, my effort for 15 minutes has wasted. Now, one second thing, I will go again in. This is 180 degree, this is 90 degree, and this is 36 degree. My question is it possible to construct a 3-dimensional figure having each face a hexagon? But now here the internal angle is 60 degree, here internal angle is 90 degree, here internal angle is 180 degree, and at each vertex there are 3 planes joining in at each vertex. Again I repeat the question.
No sir.
No. At least ट्यूबलाइट अब तो लगा
120 degree.
हाँ, the internal angle will be 120 degree and 3 120 degree makes a circle there is no space for cutting the papers and it cannot be lifted. ये जो है ना, ये खेड़े गांव में लोगों को बताया है ना, वैसा बता रहा हूँ. Actually, this should not be the way in which it used to be taught, but you do not know the technical terms. That's why I am teaching like this. So there cannot be any three-dimensional figure with equilateral, with a regular hexagon as a face. तो वॉलीबॉल और फुटबॉल आप खेले हैं सर, उसमें ट्रायंगल, उसमें क्या रहता है, उसमें हेक्सागन रहता है. Yes. So it is not possible how it is they have made it. वॉलीबॉल और फुटबॉल में जो है ना, बॉल आप देखे हैं, उसमें कौन सा फिगर्स क्या क्या रहता है. Now we have to the conclusion, came to the conclusion that there cannot be a solid figure because it will be only a plane, in a hexagon in the middle and 6 hexagons around it, and it makes a plane, that is slab. We have come to the conclusion based on the argument of the geometry that there cannot be a three-dimensional figure having each face a hexagon. But how a ball is formed?
It's not just.
It's not a triangular, it's a circular.
There are more hexagons.
Then it is three-dimensional figure means other than the plane. It is not possible. However you extend any numbers, it cannot be other than a plane. No, you are not able to. That means you have not observed. You have not seen volleyball and football. If seen, you have not observed it. Each face जो है ना hexagon नहीं रहेगा. और अगर each face hexagon रहे तो भी regular hexagon नहीं रहेगा. जब जो ना उसको उठा सकते हैं. ये उठाने की कट करने का वास्ते स्पेस चाहिए. यहाँ पर 90 डिग्री है, यहाँ पर स्पेस चाहिए. अगर वैसा रहे तो ही उसको any regular solid हो जाता है. As the number of faces increases, it attains the shape of a sphere. I think now you are following. Keep silence. As the number of faces increases, then the solid attains the shape of a sphere. In case of plane geometry, if the number of sides increases, what happens? If the number of sides increases, instead of a triangle, then square, then pentagon, hexagon, septagon, octagon, n gone. Then the limiting point is that it becomes a circle. In a triangle, in a triangle, in every triangle there will be a circumcircle, that is a circle passing through the 3 vertices of a triangle. In circle is that a circle which touches the 3 sides of a triangle. Now, for every triangle, there will be a circumcircle. That is a circle passing through the 3 vertices of a triangle. For every triangle, there will be incircle also. Incircle touches, it need not be the same center, concentric. If it is possible only in case of a equilateral triangle. In case of equilateral triangle, then the incircle and circumcircle are concentric. If not, the 2 centers will be different. Now, let this be small r and let this be big R. Now, I will first, is there any relation between R and R? Can we derive any relation between R and R? How to think and how to make research? I am taking the topic that one. R and R. Depending on ABC or the size product, name the triangle. एक AD खींचिए. AD divides BC or bisects BC only if it is an isosceles triangle or an equilateral triangle. Are you following? If ABC is a scalar triangle or असमभुज त्रिभुज रहे तो BD will not be equal to CD. Now let AB be equal to 30, AB be equal to 30, AC is equal to 50, and BC is equal to 40. If ABC is a triangle such that AB is equal to 30, BC is equal to 40, AC is equal to 50, then AD will not bisect BC. Now my problem is, I want to calculate its area. The area for the area's formula stated by Aryabhata is Tribhujasya Palashariram Samadala Koti Bhujartha Samvartaha. Tribhujasya Palashariram Samadala Koti Bhujartha Samvartaha. That means the product of half the base and an altitude, the altitude which divides the triangle into two triangles and is common for both the triangles. That means ABC is a triangle and AD is the common altitude which divides the triangle ABC into two triangles ABD and ACD, and AD is standing common to both the triangles. Now we do not know AD. How to find AD? How to find, if the three sides are given, how to find the perpendicular in that triangle? Likewise, if want to draw from B to AC, suppose B to AC another altitude and C to AB another altitude. If three sides are known, how to calculate its height or altitude? Is there any formula? Next question. If three sides are known, is there any formula to calculate the circumradius of the circumcircle? If three sides are known, is there any formula to know the radius of the incircle? ये जो ना सोचने का बात. The difference between Greek geometry and Indian geometry is this one. We were oriented in practical applications and research work, whereas Greek geometry, they have also developed geometry only philosophically, a line, a segment, an angle. Here practically, how to calculate it? Brahmagupta deals with all these questions. Some of these questions, not all these questions. And if we study Brahmagupta's geometry and misunderstanding Brahmagupta, Bhaskara has also developed some geometry. Now, there is a formula. Now, when there is a formula for the altitude, then using that formula, that is height of a triangle, we can determine the segments made by the altitude on the base by using Bhuja Koti Karna Nyaya. Bhuja Koti Karna Nyaya is nothing but Pythagoras. It was stated earlier to him in Bodhayana Shilva Sutra. Dirgha Chaturasra Kshanaya Rajyo Pashanmani Tiryanmani Cha Yat Prutalukte Tadubhayam Karoti. This is the statement of the Bhuja Koti Karna Nyaya. Welcome. Now, any question? Regarding any questions up to what I have taught from the beginning? Are there any thoughts?
Can there be a three-dimensional figure with something like more than 10 sides?
Maybe, but all will not be 10. all the faces will not be 10. Any number of figures may be there, but they are not regular figures. They are not regular figures, and each face will not be alike. Each face will not be alike. You observe in the volleyball and football, there will be pentagons and hexagons. Not all hexagons, pentagons and hexagons are different size. Next. Now, we classify triangles as acute angle triangle, obtuse angle triangle, right angle triangle, etc. What is an acute angle triangle?
Triangle which has angles lesser than 90 degrees.
And obtuse angle triangle?
One angle is
Greater than it. And equilateral triangle? Isosceles triangle? No, you have told two angles equal. You are, now what I asked, you have erred. Though you may be correct, but when I am asking as acute angle triangle, that means with respect to angle. Equal, then obtuse angle triangle, that means one angle greater than. Then what I have asked? Isosceles. So, two angles. Equilateral triangle. Next, coming with respect to side, an equilateral triangle, all sides equal. Isosceles triangle, two sides equal. Scalene triangle or scalene triangle, all the sides equal. Now, this is the definition of Greek geometry. Now we seen that in every triangle there is an incircle, and for every triangle there is a circumcircle. Can we draw any relation among the radius of the circle, circumcircle, the radius of the incircle, and the length of the sides? And depending on that, can we say whether it is an acute angle triangle? This is obtuse angle triangle. No. In an obtuse angle triangle, the height drawn on the greatest side, the height or altitude on the greatest side will be less than the radius. Is it okay? Or in other sense, the center of the circumscribing circle will be outside the circle. Why can't we say like this one? Why in the conventional way only? If we consider a triangle and it's a circumcircle, if the center of the circumscribing circle is outside the triangle, then it is an obtuse angle triangle. Can we draw this inference? Think about it. Next. If the circumcircle of the triangle is inside the triangle, then it is an acute angle triangle. If the center of this circumscribing circle is inside the triangle, then it is an acute triangle. Next. If it is on any one side of the triangle, that side will be the greatest side, and it is called as hypotenuse, and it will be the midpoint of the greatest side. So, it will be a right angle. So, instead of thinking conventionally, we should think in this way and develop the relation between the radius of the circumcircle, radius of the incircle, and sides, their altitude. This is the way of thinking, and the way of a different kind of thinking leading to research. Now, Brahmagupta. This is an isosceles. Now, if I you verified it, it may not be correct. You verified. I have put in to think about it. If they are correct, but you have verified whether they are correct or not. Now, Is there any relation between their area and circumcircle? Can we derive, if we know the area of a circle, if we know the area of a triangle, can from the area of a triangle, can the radius of the circumcircle can be determined, whether it can be determined or not? So we shall go directly to Brahmagupta's geometry. Brahmagupta's geometry. Technical terms in the Brahmagupta. There will be Brahmagupta geometry 20146. It's gone. Shloka, starting from Shloka. Now, Brahmagupta's geometry, that is plane geometry, in his Brahmasputa Siddhanta, 12th chapter, starts from the verse number 21. Plane geometry in Brahmasputa Siddhanta, in the 12th chapter, starts from the verse number 21. Read the verse.
बाहु प्रतिबाहु योगतलतः भुजयोगार्थचतुष्टय भुजोर्धातात्पदं सूक्ष्मैः
Sthula phalam, approximate area. Sthula phalam, Trichaturbhuja. This is a technical term. Trichaturbhuja is a technical term. Sanskrit scholars should give their attention here. What is this samasa? Trichaturbhuja. Tribhuja and Chaturbhuja. Or a Chaturbhuja formed from a Tribhuja. I will deal with that next. Let us, if we think that Tribhuja and Chaturbhuja, if we take the meaning of the term Trichaturbhuja as Tribhuja and Chaturbhuja. Tribhuja and Chaturbhuja. For the time being. Sthula phalam, Tribhuja, Trichaturbhuja, Bahu, Pratibahu, Yoga, Dhala, Dhata. That means if ABC is a triangle, if you want to calculate the area of that triangle based on the sides, Bahu Pratibahu, AB Pratibahu is AC, that is B plus C by 2 into A plus 0 by 2 is equal to area. This is the meaning of the first line. If ABCD is a quadrilateral, if A, B, C, D are the four sides, then A plus C by 2 into B plus D by 2 is equal to A. I think you have followed. Sthula phalam, either in Tribhuja or in Chaturbhuja will be the Bahu Pratibahu Yoga, the sum of the opposite sides, or some of the counter sides are Dhala means that is divided by 2 and take the product. That will be the approximate area. Next, Bhuja Yoga Ardha. Bhuja Yoga Ardha. Bhuja Yoga Ardha Chatushtaya. Bhuja Yoga Ardha Chatushtaya. Now, in case of a triangle, what is the Bhuja Yoga? That is sum of the sides. If A, B, C are the sides of a triangle, then what is the Bhuja Yoga? A plus B plus C is the Bhuja Yoga. Bhuja Yoga Ardha means A plus B plus C by 2. It is in case of a triangle. If in case of a quadrilateral, if ABCD are the four sides of a quadrilateral, then what is the Bhuja Yoga Ardha? A plus C plus D by 2. A plus B plus C plus D is the Bhuja Yoga. Bhuja Yoga Ardha is A plus B plus C plus D by 2 is Ardha. What he says, let it be represented by 2s. A plus B plus C by 2 is equal to 2s. That it is S, A plus B plus C is equal to S, that's why it is equal to S. If A plus B plus C is equal to P, that is perimeter. If you take semi-perimeter, that is S. Why we denote it by S means A plus B plus C is P. P by 2 is S. That is S indicates that semi-perimeter. S indicates semi-perimeter. It should Bhuja Yoga, that means A plus B plus C is equal to A plus B plus C plus D by 2 is equal to S. We keep S at 4 places. Keep S at 4 places. Bhuja Yoga Chatushtaya. इसको रब करना 4 S. Bhuja Yoga Chatushtaya. Chatushtaya means 4. Keep the semi-perimeter at 4 places in a line. Yes, 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 yes. From each yes, subtract a side. Yes minus A, yes minus B, yes minus C, yes minus D. Brackets. Bhuja Yoga Chatushtaya. Bhuja Una Chatushtaya. We have kept at the 4 places, and from one each we have subtracted the Bhuja Una. Bhujona Ghata, take their product. Bhujona Ghata Padam, take its square root of the whole thing. Bhujona Ghata Padam Sukshmam is equal to A. That line that is accurate area. Accurate area will be Bhuja Yoga Chatushtaya Bhujoda Ghata Padam Sukshmam. Now, A, B, C, D are the 4 sides. In case of quadrilateral, it is alright. In case of triangle, D is equal to 0. That's all. In case when the dimension of a side in a quadrilateral attains 0, then it becomes a triangle. So S into S minus A into S minus B. Then if you deduct it, we say it is for a triangle, and S minus A to S minus B to S minus A to S minus B for a quadrilateral. Usually, in the curriculum, this formula for triangle is called as Heron's triangle. But they say Brahmagupta has extended from triangle to quadrilateral. It is not so. It is a general case for quadrilateral. Then it is extended to a triangle, keeping D as 0. But these are the mistakes made in the history. These are to be corrected. It is our responsibility to correct those mistakes. So it is a Brahmagupta Sutra. S into S minus A into S minus B. Now, the problem arises if triangle that. It need not be ABC. ABC. Now ABC is a triangle. If you want to calculate the area according to the first sutra, that is Sthula Sutra, B plus C by 2 into A. Now if it can be also calculated by A plus B by 2 into C, right? A plus B by 2 into C, and A plus C, the 3 continue, right? 3 different things. It can be interpreted like this one.
Isn't there an A by 2?
Which one? Already have put in 2, he has taken here. Bhuja Yoga, here, yeah. Also. You will get different values for the different things. So, it can be commented that Brahmagupta was wrong. He did not know the formula of a triangle. Because we will not find a unique area in the 3 cases. If A is equal to 15, B is equal to 13 and C is equal to 14, the 3 areas calculated by the first formula will be 3 different figures, 3 different results. So, next, analysis of sample analysis. This is the formula. Bhuja Yogartha Chatushtayam Stula Palam Trichatrabhujam Bhav Pratibahu Yoga Dhalagata Bhuja Yogartha Chatushtayam Bhuja Lagata Padam Sukshma. Next. This is now criticism. Sridhara criticizes this formula. Sridharacharya criticizes this formula. Usko Sanskrit scholars read it. This is the first line of the verse number 21. Because he wants to comment about Brahmagupta Sutra. So he takes the first line of the sutra as it is to know that this is the sutra of Brahmagupta. Next. This is the comment made by Sridharacharya in his Patiganita, verse number 112 to 114. What is the content of this Sridhara? Now read. Sridhara, after reproducing in verbatim the first half of the verse yielding formula 1, add the following remarks. This is the English translation of the Sanskrit. It is said that the product of half the sums of the sides and counter sides, that is, the product of half the sum of the base and face and half the sum of the flank sides of a triangle or a quadrilateral gives the gross value of the area, but this result is true only for those figures in which the difference between the altitude and the flank sides is small. In case of other figures, the above result is far removed from the truth. As for example, in case of the triangle having 13 for the two flank sides and 24 for the base, the gross value is 13 plus 13 by 2 into 24 plus 0 by 2, it works out to 156. Whereas the accurate value of the area is 1 by 2, 24 plus 12. You got that difference. So I am giving trouble to you. An isosceles triangle having the base 24 and the sides 30. Now, 30 and base 24, triangle altitude. So, it is 5, altitude is 5 and it is 12. So, area of that triangle is half of 24 into 5. Half of 24 is 12, 12 into 5 is 60. Exact area of that triangle is 60. But according to the Sthula Sutra of Brahmagupta, 13 plus 13 by 2 and into 24 by 2, it works out to 156. So, according to Brahmagupta Sutra, the area of that triangle is 156, whereas the exact area is 60. So, Dura Bhrashtam. It is only because here the altitude is less than half of the sides. It will be approximately equal when the altitude is of the same order as that of the sides. If there is not much difference between the sides and altitude, then only it holds good. ऐसा जो है ना श्रीधर ने कमेंट किया है, वो कमेंट ठीक है या नहीं है वो बाद में देखेंगे. नेक्स्ट, ये इतना यही श्रीधराचार्य रुका था, मगर उसका कमेंटेटर जो है ना एक स्टेप आगे गए. एक स्टेप आगे जाके क्रिटिसिज्म बाय कमेंटेटर ऑफ द पाटिगणिता. पाटिगणित का जो कमेंटेटर था उन्हें एक स्टेप आगे जाके क्या बोलता है, देख, an ancient commentator of Patiganita even goes further and points out an interesting theoretical defect of the rule other than its grossness. He says, तो मैं टाइम बचाने के वास्ते स्ट्रेट जाता हूँ. They are depicted there because I am not telling anything my own. They are the translation of the earlier Sanskrit verses. The rule may yield a rough answer for the area even in the case of impossible figures. Even in case of the impossible figures, and gives the example of the triangle of base 20. If base is 20 and the two sides are 13 and 7, whether a triangle forms? No. Why not?
Some of two sides should be
Should be
greater than
greater
one
than.
side.
So, commentator himself is wrong. दूसरों को गालियां देते वक्त खुद गड्ढे में गिर जाते हैं. So, he gives this comment. His comment itself is wrong. Next, that means he says that he should have assumed that Brahmagupta knows a little bit.
When he says impossible figure, does it not mean different?
Questions afterwards.
Impossible figure.
Impossible. It is an impossible figure.
True.
Yeah.
That is in the verse itself. Not text itself says it is impossible figure.
Yeah. Everything सूत्रम. उनका टेक्स्ट जो है ना सभी लिखने का नहीं था. Only to keep in memory some texts were formed in the form of sutras. So it doesn't mean वो सूत्र में नहीं है वो तो उसको मालूम नहीं था, ऐसा नहीं है. Next. Criticism of Aryabhatta. Now coming to the quadrilateral. For the quadrilateral, yesterday we have thought that क्या था? At least one diagonal should be there. 5 independent parameters. There are only 5 sides, and at least one diagonal should be there. Then only it will be a unique quadrilateral. This in case of a Brahmagupta Sutra, area is equal to some product of the a plus b by 2 into c plus a plus c by 2 into b plus c by 2. Now he comments. कर्ण यहाँ पर कर्ण नहीं है. कर्ण ज्ञाने विना चतुरस्रे लंबकम फलम यद्वा. Va means or, that is either lamba or karna. Vaktum vanchati. Phalam vaktum vanchati. Gadako yo aso murkha pishacho va. Either he is a fool. So they criticize like this one. Next. That is in Mahasiddhanta of Aryabhatta II in the 14th chapter, verse number 70. Next. Criticism by Bhaskaracharya. Now Bhaskaracharya came into play. चतुर्भुज इसका पढ़ो.
चतुर्भुजस्य शिवतो हिरणौ प्रथमततो नियतं स्यात् प्रसादितो तच्छरणौ यदा ते स्वकल्पितौ तावितरत्रणस्य दस्तः
This is the 171th first verse of in Lilavati. उसका English. The diagonals of a quadrilateral whose 4 sides are given are uncertain. Yesterday है उसका खींचना. तो एक साइड छोटा होगा और दूसरा साइड बड़ा होगा, वो बताएंगे. तो वैसा जो है, when only 4 sides are given, it is not, the shape is not definite unless we specify a diagonal. The diagonals of a quadrilateral whose 4 sides are given are uncertain. How can then the area of it? Area is determinate. The diagonals as calculated by previous teachers will be true only in case of quadrilaterals of particular kind. Brahmagupta has given sutras to find the diagonals if we know the 4 sides. Brahmagupta has given a formula to find the diagonals, the 2 diagonals of a quadrilateral, if we know the 4 sides of a quadrilateral. He comments on that formula. The diagonals as calculated by previous teachers, that is Brahmagupta, will be true only in case of quadrilaterals of particular kind, that is cyclic quadrilateral, contemplated by them but not in case of others. It is not a general formula. For with the same 4 sides there can be various other pairs of diagonals and consequently the area also is variable. इसका जो नाम चर्चा बाद में करेंगे, in detail बाद में करेंगे. Now next. While dealing with Lilavati we shall discuss in detail. उसका वही क्रिटिसिज्म है. हाँ नेक्स्ट. हाँ और फिर जो है ना ब्रह्मगुप्ता का. Next. So when we develop geometry, we should also look into the fact that what is the geometry taught by Brahmagupta, how it is understood by and misunderstood by the later scholars. We have to trace out the development of geometry. ऐसा अगर development of geometry देखें तो their way of thinking हमको मालूम होता है, नहीं तो we can't understand the geometry clearly. So let us stop here. Time doesn't permit. We take it further in the next classes.